All right, good morning, everyone. Welcome to Understanding HL7 2.0 Standards, Pen Testing and Defending HL7 2.0 Messages. It's presented by Annie, and you are in the Jasmine Ballroom. Before we begin, a few brief notes. Please remember to stop by the Business Hall located in Bayside AB. The Black Hat Arsenal is in Palm Foyer on level 3, and there's an Arsenal reception there at 5 p.m. If you haven't picked up your Black Hat merchandise, today's your last day to do so, so visit the Black Hat store. There's also a Kali Linux workshop being held all day in Mandalay Bay A, and please remember to put your cell phones on vibrate. Let's get started.
Thank you. So this one. All right. So I'll just start with the presentation. So it is HL7 2.x security, so it's on medical devices. It covers all medical infrastructure. So if you have friends and all, the topic was a bit abstract. So I think people didn't know it. So I'll just start. I work with Philips Security Center of Excellence. I like green technology, and I follow Null and Sysinfo. So you want to check these communities, fabulous communities. I was a chapter leader for Null. I will be starting education next month. I will be in Boston. So if you have research topics, just drop me a mail. Find me. I run hospital security project. It's on medical device security and hospital security. I've started a mailing list, which is hot, if I know. All right, so this is the mailing list. Just check on that. Today we'll be talking of security inside hospitals. We'll take a crash course on HL7. We'll try and understand what these messages are, the value that they hold. The reason why I researched on this topic was when I started with product security, I didn't have any idea about this, and there was no resource available. So I started with the list of vulnerabilities, how do you test these messages, and then how you attack these messages as well. Okay, let's talk of securing hospitals. So when you talk of securing hospitals, these are the key focus points. So you talk of securing devices, you talk of securing networks, the protocols. All right, okay. It's my cell phone. Okay, so you talk of devices, networks, protocols. We'll be talking about HL7 2.x, 2.x. The same concepts relate to 3.x as well. And then we have patient records, but I'm not doing that right now. All right, what is HL7? So this is the HL7 definition. What it says is it's the biggest standard for medical exchange, data exchange, helps in interoperability. The 2.x version is run by about 95% of all hospitals in the US, and it's supported across 40 countries. Besides that, it's the largest association for medical standards. In a nutshell, HL7 is everywhere. It is used by medical devices to support interoperability. So when we talk of HL7 messages, you'd find this. These all messages being transferred over HL7 2.x. So let's just deep dive into the system and let's see what it is. So when you talk of an HL7 message, this is what you find. You have a raw socket. It starts with a 0xP. It runs over TCP/IP. So you have this is the start of the message. These are all segments. So this is where you put in your text data, and then you have the ending block and the carriage return. This is how an HL7 message looks like, and this is how it looks like in real. So this is just the first line of an HL7 message. This is the MSH segment. Whenever you see an HL7 message, this is the most common delimiter. Please note that this can change with different standards or different vendors. So the pipe symbol means there's a new field. The caret means space. So if I were to say John Doe, the space between would be between them would be given by the caret symbol. All right, MSH is the header. So there are a lot of messages that go around. At this point, I'll be talking of only 4. for yes. The reason is there are many other messages, but I just wanted to focus on this in the interest of time and the importance of these messages. We'll see MLLP protocol in detail. All right, so let's jump on the messages. So ADT, this message is responsible for registering a patient. It says admit, discharge, and transfer. This is responsible for admitting, discharging, and transferring the patient. If you look at over here, this is the first segment, which is MSH. The EVN segment, which is the event segment. This is the patient visit segment and the OBX segment. Do not worry about this. Just get the hang of it, and we'll see. We'll use tools to decipher messages out of this. All right, so this is, it contains patient information. So if you gain access to these messages, or if you're running Wireshark over a network, this is what you get out of these messages. So you can get patient information, and there's much more you can get out of this. The doctor information, patient visit details, the allergy. Now, if an attacker were to intercept these messages and change the allergy, it'll be bad. So this is what so Alan, who reviewed the slides, told me that it can have a negative patient impact. Right. So potential entry points. So when you look at HL7 messages, it really depends on the context and what you're pen testing. Because much of these systems do not have a GUI, but they would have legacy systems. They can have patient monitors, so you have to fine-tune your attacks. If in case of EMR, look at JavaScript and injection attacks, buffer overflows, EMR systems will be a prime target. Let's move on to the next message, which is the ORM. So I believe this is one of the most important messages that goes around. If you're on diagnostics, this is the message that goes. And if you see at this message, this says the SSN number, which can be present over the ADT also. And it has diagnostic segments. So it has the OBR segment over here, right? So this segment is responsible for sending out patient vitals. So if you like on a blood gas analyzer or a BP machine, these messages will be there. So as an attacker or as a malicious user, if you gain access to this and change these messages, this is a big problem. This can be used to place orders, ultrasound, MRI. It has patient information like ADT. Some can have more information. It can have order details. Now, if you gain access to these messages, you can get you can take an educated guess that there are more devices connected to the same infrastructure. All right. So think of this: if you were to place a MRI scan, this message would be sent. So I know inside the hospital network that there's a machine, which an MRI machine present. All right. So the potential entry points are changing PII, changing diagnostics, and changing observations as well. This is the final that we'll be talking. This is the observation result. I'm sorry I messed it up with the previous one. This is responsible for if you run an ICU, these are the messages that are sent. Right, so these given real-time information on the patient vitals. So if you look at over here, it says respirations per minute and then services. All right, so the important observations on this are patient information, heart rate, oxygen levels, any real-time information, and it can be used to harm someone, change diagnostics. The potential entry point is the OBX segment and reflected file downloads. We'll talk about the reflected file downloads later, and I'll show messages. All right, so we have another final. So this message is responsible for gaining access to medicine. So if you prescribe any drugs, this is the message that is sent. All right, so used for providing medicines, it can change you. So if you gain access to these messages, you can change the dosage, change your dose as well. So you can gain access to non-prescribed drugs, change someone else, harm someone. Again, potential entry points include PII, pharmacy, the root segment and observation segment. That is it. That is all you need to know about these messages. let's just jump to how do you view these messages and how do you attack these messages. You can capture these messages using Wireshark, but if you're running this on a live environment, be sure you have a really powerful machine. A typical trace over a hospital network, within 5 minutes you get GBs of data. That is why pen testing these messages becomes a little hard. So you can gain access to HL7 dumps. What I use is Smart HL7 Viewer. It's free and really effective. So let's see how these looks like. All right. Can you mirror my screen? No? All right, cool. So this is an ADT message. If you look at the EVN segment, this is the information that you have. So this is how an ADT message looks like. This tool gives me all of that information. If you look at the PID segment, just look at this: the patient ID, patient name, the sex, place, patient address, patient account number. Right. So the reason why I find security researchers find it hard to pen test these messages is because we're not shown data in this way. Right. So if you look at the PV1 segment, this is all information that is there. And it really depends on the infrastructure that you're looking at, because there can be more information on this. So on this particular message, this one, this all information is there. So you have the OBX segment, and you have the allergy segment. Okay, so the patient is allergic, has been given the allergy code aspirin. Imagine changing this. Again, so you have diagnostic segments as well. So if I were to mess around and I change this segment, it becomes a problem again. So this is the order message ORM, and we'll just see. So like the ADT message, it has the MSH segment. This has a security segment as well, and we'll talk about it later. If you look at this is interesting because this has more information than the ADT message. So you cannot pinpoint to any particular message. You cannot say that just the ADT message needs to be protected. Every message holds some significance and can hold much more data. If I scroll down, you see here. So the SSN number, driver license number, birthplace, birth order, nationality. Again, so there's a lot of information on this message as well. Again, the patient visit one. So just look at this. So you have the attending doctor, registering doctor, and a consulting doctor. This is what the messages on a hospital make. Why these messages are more sensitive, because you have all of this information just being sent across like that, right? Right. So if you look at the other segments, OBR, so there was a chest X-ray ordered, and the request date and request time was also present. Right? Pardon? Yes. So yes, it does. So ADT. So don't just think of this message as a subset of ADT. ADT is a different message, but they can hold the same information. The segments is what the information holds. So between them, the only thing is this guy over here. So this guy over here actually tells you what kind of message it is, and it will be routed to the correct interface. So if you look at this over here, you have the OBX segment. An interesting thing is you can, observation method, you can change this over here also. All right, so this is where this is the most important message that I was saying, the ORM. So if you're lying in an ICU, these are the messages that are sent. And if you look over here, it says display row, services, responsible owner, but then you have observations over it, right? So this is the respiration rate, and it says that specimen received. This is what makes these messages really, really important. Now the RDC message. This is my favorite message again. Just look at this segment over here. If you're a very targeted, if you're doing a targeted attack, you would like to see this segment and replay this, right? So even if you have automatic vending machines, you can replay these messages and see if you can gain access to unauthorized drugs. Right? So if you look at the RXR segment, it says O'Reilly RXA segment. It says, this is the administrative code, the administrative notes, and remove last. All right. So now let's start with attacking these messages. All right. So. All right. So how do you find these messages? A big problem on finding these messages is this is what you get on a board scan. So there are no standard ports on HL7. It really depends on the vendor. It really depends on what you're looking at. Right? So I, as an administrator, can run these messages over any port that I want. And so how do you find these messages is try sending the appropriate first, identify the port, find the appropriate message, and then try attacking these. Right, let me just show you a video. So I have demos prepared on video because the demo gods don't really like me. So yeah. So if you can see over here, what I did was, this was the IP that was running HL7 messages. So this is a listener on HL7. You would find this on EMR or compatibility software inside a hospital. When I start a scan, I do an intense scan, all TCP ports. Now, keep in mind, if you're doing this on a live hospital environment, do not go for an intense scan. The reason is some devices might crash. I've not seen devices crash on me, but I've seen some researchers come up and say, oh, we've crashed a medical device by just running an Nmap port. This is an infrastructure that I control. So I can run an intensive scan. All right. So I'll just skip to the end. All right. This is what you get when you scan. So you get this. So I'm running HL7 ports or interfaces on 2007, 9001, and 10200. What Nmap shows me is TechTalk as Tor or port and 10200. Now this is interesting because if you're pen testing or auditing a hospital network, you might need to think that why are these ports open? Why would someone run Tor? The simple reason is I could run interfaces and messages over this, and that is why it becomes these messages become really deceptive. You need to really figure out what is the right thing. So this is how a scan looks like. All right. So what makes me think, cool. So now we do understand that we have HL7 messages running over this port. Let's see if we can pen test and find information about these or the services that run over this. So this is a script that I've written, main.py. I will release it after the conference, so you can find it on my GitHub. So I specify the IP over this. So right. I do specify the port as well. So I said 10,200. So if you remember from the slide, it says I said a port which says MSH. Now what happens is you cannot pinpoint on that is this server running HL7 message, because this is not how MLP works. So it's more of a hit and try and an error-based detection. What we've done is we've sent just a part of the segment, so the MSH. In some segments or in some systems, what will happen is the system will come back and say that this message is not supported, or you've sent a wrong message. These messages are supported. So it'll just look at the behavior over here. So I sent the MSH. I received nothing. And the reason is, the interface did not understand, or it's just a false positive. So I now send and MSH. So this is a lowercase MSH. Now this is not exactly a standard. So the system would come up and say, and a knack. All right. So the system said, I did not understand what message you sent me, and that is why I got an ACK. Now this confirms that the system is running HL7 port. Now I need to figure out what is the message that it accepts. So I send an ATT, and yes. So this is the message that is sent. Wait. All right. So this is by this I'm really sure that the ADT is supported. Right? Now I can understand that maybe there's a registration desk, right, which is running inside the hospital, and this is the port that is running. So now you can prepare your test cases on that. Now how do we find other messages? We'll see. All right. So this is an interesting demo. So what I'm doing is every IP can have multiple HL7 ports, or it can have multiple HL7 messages sent to the same port. For the sake of convenience, what I did was I'm running 3 different ports. This is the second port that we're talking. So this is port 9001. So this is an emulation tool that I'm running. I will release this soon also. So I sent a message and it just responded me just like that. So it says I acknowledge the message. So let's see what happens next. Say port 9001. All right, so the ADT message is supported by this, right? So because it's an emulation tool, you have the ADT. Now, so what is the significance of this? Now, if I send in junk data, let's look at what happens after that. So if I send a message, just the message segment, this guy crashes or goes into a limbo because it doesn't understand what to do next with this message. Right, so this becomes, these are all neat hacks to even do. So ultimately I have to quit it from the script because it doesn't work. All right, so this goes in for, if you were to fingerprint ORU message, so this is port 2007. So some systems, so if you see a message, so it says message received, and this was the message that I sent. All right, a message. So, and it says over here, invalid message. It gave me an acknowledgement, and it said an invalid message. Right. Now, this is important when you're testing specific messages. So you want to know that is this particular instance only supporting a particular profile, and these is when the messages come in handy. So I try and brute force. So I say ms message and I say ADT. Again, I got an invalid message. So when you're pen testing live systems, this will happen. All right. So because it is listening for a particular profile, and I send the ORU message. Now I got it. So if you look at over here, it says an acknowledgement. All right. So now I know that this interface is listening for ORU updates. Right. So if you have an ICU, this is where all these messages will go. Okay, so common flaws with HL7 2.x. Man in the middle attacks. So this is an implementation flaw. What happens is, does everyone know about MITM attacks? Anyone who doesn't know about man in the middle attacks? Tough crowd. All right, so what happens is, So I can route the traffic through my system. I can do an ARP spoofing attack, and I can sniff all the messages. It happens due to insecure configuration. I've seen this hospital do this, but the particular reason is that it takes time to install certificates on each system and enforce TLS. All right, and I've seen this come from hospital techs, and they said, it takes time. There's lack of support, and there's cost involved. Message source is not validated. Now, this is a problem when you have a bigger infrastructure. So let's say you have a patient monitor which is sending messages to your EMR system. EMR is electronic medical record. Now, what happens is these two guys know that the EMR is listening over a port, but it doesn't really care that where is the message coming from. As long it is in a particular format, it will start processing it. Right? So this is, just think of it like a broadcast. This can lead to rogue messages. So if I'm a malicious actor inside a hospital network, I would send in fake patient ADT messages. I can fake ORU messages as well. You just need to change the timestamp, because then it'll go ahead, override, or discard the messages. So if you're sending ORU messages, just change the timestamp, and it'll accept just like that. Unvalidated sites. We'll see a demo on this also, unvalidated sites. What can happen is a DOS attack, and we'll see how we do a DOS attack over it. So HL7 by design does not specify that what is the maximum size of a message. That has to be implemented by the vendor, and you can use that weakness. File download of. So the way HL7 works is that you have a particular segment. If you have a test scan done, let's say an MRI or CT scan done, it'll point to a report, and you the interface goes there, picks up that report, and shows it to you. In all chances, this is over a web system. So you can replace PDF files with backdoor shells, and this can lead to SSRF attacks. Right? We'll see the particular segment which is responsible for, and this is just one part of it. I'll just show how it looks like. So let's say logo. Okay. So look at this. So this is where the report is kept. So it says MR test.pdf. Right? So if I were doing a man-in-the-middle attack, change this. Or if you were doing, let's say, pen testing these messages, change this message to actually point it to some other port on the same server. You can also use this message to gain access to other patient records. Because I know that this is a shared drive and I'm on the same network, I can actually go ahead to this hospital and this drive and check if there's an authentication present. This becomes a problem when you're running a live environment. All right. All right, bad server attacks. So this is like my favorite attacks because I discovered this and I really feel nice. So what happens is on every message that we send, an ACK is sent, which is the acknowledgement. Now, what if a rogue server is present over there, and you have a patient monitor or device which has low memory footprint? Right? You can use that server to actually attack other interfaces. So if you own an EMR system, you can try and attack all other tertiary devices of the system, and we'll see how. Let's first understand that ACK means an acknowledgement that the message has been received. A NACK indicates to send the message again, like we saw in the first demo. It said, NACK, I do not understand the message, send it to me again. This is how a message looks like. So MSH, this is the responder, this is the name of the responder, this is the acknowledgement, and this is the acknowledgement number. This is sequential, so it says 001. In some, you'll have base 64, or you can have random sequence. At all times, it's not exactly random. It's actually a part of, it can be a proprietary sequence, or it can be just an incremental hexadecimal. But it's an increment message. Now, what happens if I do this? Right? And so, other problem is, what if I do not send any acknowledgement at all? What if I own the server and I stop sending acknowledgements? Now, what happens with any system is it'll send the message again. So let's say you have a patient monitor, right, which is sending your blood pressure updates. and I'm sending an acknowledgement which looks like this. What happens is the patient monitor thinks that the message is not complete, so it will send the message again and again and again. Right. So what ends up is you try and send the same message over and over again. So if you have a blood pressure of like say, which is falling, like 60 or something, it'll send the same message again and again and again. Now that has to be configured on your device. It has to purge messages after a particular time, which is a configuration flaw that I find missing in some of the hospital environments. So this is a potential loss, and we'll see how it looks like. So if you look at over here, so right now we're just sending messages. So this is how it looks like. All right. So if you get these kind of messages, now this is a very plain example of sending just a long string. I could go ahead and sophisticate these attacks for a particular device or a particular vendor and have malicious code over this. All right. So, yeah. All right, let's talk of fuzzing HL7 interfaces. Now, I wanted to take up this because the current the vendors that I see who are fuzzing HL7 interfaces, it's a really prime. I don't feel the message they fuzz it the right way. The reason is they would have a file which they assume that would work for every medical device. It doesn't happen like that. You have to understand the context and the interface that you're attacking. So what is the interface? What is the connected infrastructure? And then you attack the system. Let's take an example scenario. So I open this. So what happens is, if you talk of vendors, what they'll do is, instead of this message over here, and I'll magnify this, they would send a payload which is a very generic payload, and it would send it across everywhere. So it'll say a message and it'll send it, they'll send one big payload. That doesn't work out. It can work out on devices which have low memory, which cannot handle that. What you really need to do is understand these segments. So are you fuzzing the daytime observation? If there's a legacy systems that holds patient records, you might like to fuzz this particular instance. That is how you create a fuzzing environment, instead of just a brute force over the whole message. And fuzzing can be very, very difficult in HL7 interfaces because you already have GBs of data, and these guys can handle that data. So you can run fuzzers for a lifetime, nothing will work unless you understand the particular point of entry. All right, so let's see some defending HL7 messages. All right, let me show you some demos. How much time do I have? All right, awesome. So if you look at an Wireshark trace, this is what you'll get. So I just ran a Wireshark trace, and I was running on 0.8. Just follow that stream. And this is the kind of message that you'll get. Right? So it's just plain text. And imagine handling this data in GBs. So you need to be very particular about what you're attacking. If you see this, these are all overview OBX segments and overview messages. And right, so what I'll do is I'll scroll next, and the only thing that will change is the timestamp. All right, so these are about 632 packets. This was in about 5 minutes. In a hospital environment, this will be huge. All right, let's talk of DOS attacks. So these are the demos that I prepared like last night. So what happens is, we were talking of file uploads, right? And we were talking of unvalidated sizes. We'll use that kind of a weakness over here. So what happened? So what is happening over here is, I sent a message, which was an ADT message over 9001. I sent the same message here. The thing was responding. Now, I sent a DOS message, which is technically it's a very big message. This is a small, and this is a very small interface. This guy is still running over here. This over here, it's still sending messages, and the other stream just starves. It'll just wait for the stream to be released, which doesn't happen. And so this is how you do a DOS. But so I can stream to the next. So ultimately, if you see over here, I stopped the DOS over on this, and I send the ADT message again. All right, and start working. All right. So, but this is an emulator. This is a very small system. If you talk of large systems, what will happen is this. So you send an ADT message. I know this this runs ADT, and I get a response back. So look at the response. I got a response like really quick in about 1 second. I say a DOS. So let me just. So I'm sending DOS packets. So it's just that I'm sending really big packets, nothing huge, but it's just the functionality I'm trying to abuse. Now, if you look at this over here, this guy doesn't receive any acknowledgement. And we've been waiting for quite some time, and we got an acknowledgement. So what I do next is I send more of the streams. So what I'm doing is, if you look at EMR systems or any solution, it'll have streams. So it can accommodate a maximum of 5 clients or 10 clients at one time. If you fill in all of this, there's nothing on the defense side that you can do. That is what I'm going to do right now. I sent, these are like 4 terminals that are running. And just look at this ADT message. So these are 3 terminals that are running, and I do a 4th one. This is like just take care of it. So now it'll just wait. So all the streams that were there have been occupied. So this guy would not receive anything. So yeah, that is how it does. Yes. All right. So finally. So these are all demos. So yeah. Finally, so validate the message size. What I feel is TLS is very important in hospital environment, and we do not think of implementing TLS over these messages. The reasons, we talked of the reasons earlier, but this has to be like a bare minimum in all hospital infrastructure. The costs are there, but it pays in the long run. Look for unvalidated file downloads, and this is an issue what I feel with vendors and developers. They would say, oh, it runs in a hospital environment, it cannot communicate to each other. But then I was talking to a hospital admin, and he said, the doctor in the duty wants Facebook on the system. So he uses internet over a Windows server because he just wants it, because he gets bored in the late shift, so he wants Facebook. All right? So have input standardization. I mean, everyone from the security industry would understand this. Have fault tolerance. Have automatic purging. If your messages are failing, just look at purge messages first, because you do not want old patient data to get updated. In case of ICU systems, anonymize HL7 messages. Now this is a practice I've seen with some hospitals, wherein if a VIP comes, they would use a different alias altogether. Right? But there's no point of sending all of this patient information in every HL7 message. Track patients using an MRN number, which is medical record number, and that should do the job. a use segment. So the ST segment is was specified by the HL7 folks, 2.x folks, but I've not seen anyone use it. So they said that you can use a rolling code for the message, but I've not really seen someone use it. Finally, secure network, firewall, both ingress and ingress. So this is one thing. So if you go to the dark web, you can see a lot of hospital networks. So don't assume that the hospital network will not be compromised. All right. Understand your network and devices, and this is important. What happened was I was not feeling well. I was taken to a patient or hospital. The first thing that I did in a hospital was connected to the Wi-Fi and scanned the network. So it's like, yeah. After that, my friends did not take me to the same hospital again, and they didn't go to the hospital with me again also. So yeah, just look at that. Have private and public networks separate. And the interesting thing was, in another hospital that I went, there was a Wi-Fi network which says administrative network. If I'm a serious attacker, I would try and brute force that network as well. So do not put everything on Wi-Fi, unless you really, really want it. More work to follow soon. First, follow the hospital security project. Before ending, I would like to thank Michael, Ben, Minati, everyone from my team in security. Michael is here, you can meet him. All right. I will take questions now. Yes?
So you said some facilities don't use encryption. Wouldn't that be mandated under HIPAA laws or no?
Yes, it is. But
They still don't do it?
But yeah, so it is mandated. So what I could understand out of the HIPAA laws was, HIPAA says that as a medical device vendor, you should support encryption, but it does not specify how does the hospital implement that encryption. Right? So it's up to the vendor to have a provision for encryption. But if you talk of a hospital network, they might not use the feature at all. Right? So again, yes. More questions? No? So should I end it? Oh, okay.
About encryption, under HIPAA, encryption is not a requirement. It's recommended, and what that means under HIPAA is that you do a risk assessment, and if you feel or your management feels that encryption isn't feasible, for example, if they think it costs too much, whatever that means to them, they don't have to encrypt. So that's an argument you're going to have to be prepared to have with people who are looking at dollars and cents.
Thank you. Yes.
My understanding is HL said don't only ask a question
Yeah, under HIPAA, encryption is strongly recommended rather than flatly required. If you do a risk assessment or your management does a risk assessment and they decide that for financial reasons or performance reasons that encryption is not practical, they're not required to do it. They just have to document the decision that they didn't. So that's an argument you're going to have to be prepared to have with people that don't want to spend money.
So my understanding is HL7.3 includes secure messaging.
Yes.
As well as, I think it includes message size within the payload.
Yes.
Are you seeing version 3 implemented or?
No. So HL7 3.x is, it's a sad thing that it is just used by the people who invented it. So there are some hospitals which are proponents of the technology, and they're the ones using it. It is a XML-based system, so you can have all of these in place. So you can have message checksums, you can have bad messages in place, but I've not seen it being used as widely as 2.x. It's being used in really about 1 or 2% of the world hospitals. That it might be less or more, but it's really less. HL7 2.x is huge. It's being used across every hospital in the US, and it'll stay for about 20 years. This is what I believe. Yes.
Does the 2.x standard have some way to prevent replay? Because, with the Wireshark,
Yes.
you're capturing it.
Yes.
So if you don't do man in the middle, I mean, is there any type of...
So I'd answer it in a different way. So if you're looking for upgrades, look at FHIR standards. The 3.x is, in my opinion, is not the best upgrade because, so here how it goes. So you have HL7 2.x, then you have 3.x, and then you have FHIR. FHIR is currently rolled out, and it has provisions for all of this. It has access management as well. 3.x does have provisions for it, but I would not recommend you to upgrade on that. To just go for FHIR from 2.x to FHIR. And a lot of the industry is moving at FHIR at a really fast pace. So all your patient bands and monitors or some of the portable medical devices work on FHIR right now. So it's going to be a transition from 2.x to 3.x directly. 2.x to FHIR, I'm sorry. Yeah. Any more questions? We have like 2 minutes. All right then. All right. Thank you.